Welcome to David Alexander Maths Tuition. This is chapter 12i, stationary points. Find the coordinates of the stationary points of the curve y equals 2/3 x cubed plus 1/2 x squared minus 10x plus 7. Okay, so what we need to do first of all is differentiate. So dy by dx is 2/3 of 3, 2/3 times 3, which is 2, so that's 2x squared plus half times 2 is 1, so plus 1x plus x minus 10. Okay, so we need to remember that the stationary point is when our derivative is 0. At a turning point, the stationary point, the gradient is 0. Okay, so therefore 2x squared plus x minus 10 is 0. So a bit of a funny one, this one. I'm not sure if it factorizes. It probably does. I just too lazy to bother doing it. So that's 2x squared plus 1x minus 10. So x is 2 and x is minus 5 over 2. Okay, so what we need to decide is what is the gradient either side of 2. So it could be that we have where x is 2, that could be a local maximum, or it could be a local minimum. We don't know. Well, we can find out. So what I need to work out is what is the gradient to the left of it. If the gradient to the left is negative and the gradient to the right is positive, then it's a local maximum. However, if the gradient to the left is negative and the gradient to the right is positive, then it's a local minimum. Okay, so what I'm going to do is I'm going to say, so let x equal 1.9. So what is 2 times by 1.9 squared plus 1.9 minus 10. So when x is 1.9, dy by dx is negative. And let's try let x equals 2.1, because it could be that it's negative on both sides, in which case this might mean it's a point of inflection. So 2 times 2.1 squared plus 2.1 minus 10, and its dy by dx is positive. Okay, so if it's negative to the left and positive to the right, then this means that when x is 2, when x equals 2, the stationary point is a local minimum. Okay, how about when x is minus 5.2, so minus 2.5? So if I put negative 2.5 into our gradient function, I'll get 0. But what if I put in, let's do a tiny bit less. So let's do minus 2.6. So minus 2.6 equals 2 answer squared plus answer minus 10. Okay, so it's positive to the left. And let's try minus 2.4 to the right. Minus 2.4 equals 2 answer squared plus answer minus 10 is negative. Okay, so when x is negative 2.5, to the left of it we've got a positive gradient, and to the right we have a negative gradient. So therefore this is a local maximum. So it's all about just thinking about the gradient either side of that stationary point. Okay, so there's another way we can determine the nature of stationary points. So first of all, is this exactly the same one as we had before? Yes, it is. Okay, so dy by dx is 2x squared. Dy by dx is 2x squared plus x minus 10. So now if I do d squared y dx squared, that is going to be 4x plus 1. Now, what were the stationary points again? It was x is 2 and x is negative 2.5, I believe. Let's just go back and double check. Perfect. Okay, now if d squared y dx squared is positive, then that means it's a minimum point. But if it's negative, then it is a maximum. Okay, so let's chuck 2 into here. 4 times 2 is 8 plus 1 is 9. Okay, so since 9 is positive, that means this is a minimum point, but we knew that already. And when x is negative 2.5, 4 times minus 2.5 is whatever, plus 1, we are getting negative 9. So since we're getting a negative answer, that means that this is a maximum point. Find the coordinates of the stationary point of the curve y equals 4/3 x cubed. So dy by dx is 4x squared. So let's set that to 0. So 4x squared equals 0, therefore x squared equals 0, x is 0. And when x is 0, y is 0. So this is the stationary point. Is it a local maximum, a local minimum, or a point of inflection? So let's do our d squared y dx squared. So that is going to be 8x, and x is 0. 8 times 0 is 0. Okay, so that could mean, it doesn't mean it's definitely a point of inflection. We need to consider the gradient on both sides. Okay, so let's just be clear here, when d squared y dx squared is greater than 0, then we get a positive value, then that is a minimum. If it is less than 0, it's a maximum, and when it equals 0, it could be anything. We need to do further investigation. So what I'm going to do is I'm going to look at the gradient just to the left and just to the right. So let's let x equal minus 0.1 and x equal positive 0.1. So what is the value of dy by dx when x is negative 0.1? So here we're using the first derivative because that's the gradient function, not the second derivative. So negative 0.1 equals 4 answer squared equals 1 over 25, so it is positive. And when it's 0.1, 0.1 squared times by 4 is also positive. Okay. So if this point 0, 0 has a positive gradient on both sides, then that means it is a point of inflection. If it was positive, then negative, it would be a local maximum. If it was negative, then positive, it would be a local minimum. But because it's the same, both positive and positive, then it's a point of inflection. If it had been negative and negative both sides, that would also have meant it's a point of inflection. So when the second derivative equals 0, further investigation is required to see whether it's a local maximum, local minimum, or a point of inflection. Find the least value of the following function. So we need to remember that the least value or the greatest value is the turning point, where the gradient is 0. So let's do our dy by dx. So that's 2x plus 7. And as I said, it's the turning point where the gradient is 0. So we need to set our gradient function to 0. So 2x is negative 7, x is negative 7 over 2. So the least value is generated when we have an x value of negative 7 over 2. So what is the least value of the function? Well, that's when we input minus 7 over 2 into it. So grab your calculator, minus 7 over 2 equals answer squared plus 7 answer plus 32. So y equals 79 over 4. So that is the least value. That is the turning point of this quadratic equation. Find the greatest value of the following function. So again, we need to do our dy by dx. There's the greatest value here because this is a negative x squared graph, so it's an n-shaped graph. So we want to work out the turning point basically. So that's going to be minus 2x plus 13. Now the greatest value is the turning point where the gradient is 0, so let's set our gradient function to 0. Add 2x to both sides, so 13 equals 2x, or 2x equals 13, so therefore x is 13 over 2. So the greatest value is generated when we input 13 over 2, and the greatest value is what happens when we input 13 over 2 into our function. So it's the y value. So 13 over 2 equals, so minus answer squared plus 13 answer, take away 65, and it is negative 91 over 4. So this is the greatest value of that function, and it's a negative one as well.